Okay, so it says that the doubling period of a bacterial population is 10 minutes. At time 80 minutes, the bacterial population was, what's that, 60,000. What was the initial population at time 0? And then find the size of the bacterial population after 5 hours. Okay, so let's take a look. Here I have something from the exam for notes, which are right at the top of the Unit 4 module in the Canvas course shell. So it's for doubling or halving problems, either one. It's basically the same deal. So I give an example here, but I give you a doubling formula is A equals P2, there's the doubling, to the power of T over the doubling time. And then I give you the halving formula, which is the same thing. It just has a 0.5, which is half, right? Instead of a 2. See the 2 and the 0.5? Doubling and halving. Times 2 and times 0.5, half. Both to the power T over the halving time or T over the doubling time. So on this example, I'm using the halving formula, and I say plug in the given information and find the initial mass. So that's what we're going to do here. So first off, let's start with the doubling formula, which is A equals P 2 to the T over doubling time, right? So that's in the notes. That's the doubling formula. So specifically, that's going to be P2. What's the doubling time? The doubling period of a bacterial population, 10 minutes. So my example, it's 10 minutes. You might have something different on yours. So there we go, right? The doubling time, 10 minutes. Okay, now what are we going to do? Well, it says plug in the information. So step 1, plug in the info. Plug in the info. What info did they give us? Oh, it's just bugging me how bad that came out. There we go. Plug in the info. They told us at 80 minutes, there's 60,000. At T equals 80 minutes, the amount in the bacterial population is 60,000, right? At 80 minutes, 60,000. So let's plug that in. 60,000, 80 minutes. So we'll get 60,000 equals P times 2 to the power of, it's going to be 80 over 10. Is that good? So I just plugged time 80 in for T. I plugged the amount of 60,000 bacterial in for A. Okay, now notice we only have one letter. So we can solve for the P. So how do we solve for the P? Well, I do a little bit of math. So 60,000 equals P times 2. And then 80 divided by 10, well, that's 8. And then 60,000 equals P. And 2 to the 8th power, just use your calculator. 2 to the 8th power is, what is it? 256. 256. Right, like that. Yeah. All right. And then finish solving. You know what to do. Divide by the 256. Boom. So we got P, whatever 60,000 divided by 256 is. I'm getting 234.375. So there's our first answer. P, and what did they ask? They said, what was the initial population at time 0? That is the P. That is 234.375. I don't know if they want you to type it in that way or they just want you to say 234. whichever, because you can't really have part of a bacteria, right? 234.375. So, okay. So next, so that's the first thing. We found P. P in the formula right here. P is always the starting amount. Let me write that. P is always the initial or starting amount, P. That's always what P is in these formulas. Like in a banking formula, like if you're an investment, P would be the principal amount of money, the amount of money you put in the account at first that then grows to become something larger later. So P is always the starting amount of money or the starting amount of bacteria or whatever. So we found the starting amount, 234. So it looks like 234 bacteria started off. Okay, next question. It says, find the size of the bacterial population after 5 hours. If you look at the notes, I basically say, so step 1, get the formula. Step 2, plug in the information. Step 3, plug in the final time. So now we're on step 3. Well, I guess this was step 1 technically. This was step 2. Step 1, get the doubling formula. Step 2, plug in the information. Step 3, plug in the final time. And what it says is 5 hours, right? You know what it says? Yeah, 5 hours. So it wants the size of the bacterial population after 5 hours. So 5 hours. Now, our formula is A equals P 2 to the, what is it, T over 8? No, T over 10. T over 10. T over 10, right? I'm just grabbing our formula from right here. Right, because the doubling time was 10, so that's what goes down there. Now, we now know the P, right? So let's plug in. P is 234.375, which we just found in the last part. And T equals, now should we plug in 5 for T? It says 5 hours. No, I hope you know no is the answer to that. Why? Because we're using minutes already. What do you mean? Where are we using minutes? Right here, right there, 10 minutes. And so when we put that 10 in there, all of a sudden now our time units are minutes. You can't mix. You've got to be minutes all the way or hours all the way. You can do either one you want. You can do days and weeks. So it doesn't matter. So when it comes to time in a math or science formula, you have to be consistent. So if you start with minutes, you've got to make everything minutes. If you start with hours, that's fine. You just got to make everything hours, etc. You can't change your mind halfway through. You've got to have one set time unit. So I started with minutes without even thinking about it. That's fine. But then when I get to 5 hours, I've got to change that to minutes because my current formula is in minutes. So, okay. So 5 hours, you know how to do that. Not a problem. Times 60 hours in every, 60 minutes in every hour would give us 300 minutes, wouldn't it? 5 hours is 300 minutes. So T is 300. We're going to plug in P is 234.375 and T is 300. So put in the 300 there, put in the P there. So the P, which is 234.375 times 2 to the 300 over 10. Is that good? So I plugged in the time, 300 minutes, that's 5 hours later, and I plugged in the P. Now, this is 234.375. This is 2 to the 30th power, right? 300 divided by 10 is 30. All right. And then hit the buttons on your calculator. It's going to be a big number. I don't know how this is going to work. Yeah, I got a crazy big number. All right, let me tell you about this number. So I got 2.5165,824. And then I got this E11. I don't know how your calculator does it, but what that means, let me explain this. This means exponent. That E stands for exponent. It's the exponent. It means times 10 to the 11th power. It means the exponent is 11, which means, more importantly, it means move the decimal 11 places to the right, because it's a positive 11. It's your calculator's way of giving you scientific notation. It's saying times 10 to the 11th, which means this decimal needs to go 11 places to the right. How do we do that? 1, 2, 3, 4, 5, 6, 7. There's 7 jumps to the right. So beyond that, there's got to be 4 more jumps. We don't know what those digits are, but I'm just going to bring in zeros. I really don't know what those digits are. The calculator isn't able to show us. So, but I know where the decimal has to end up. Does that make sense? It was right here between the 2 and the 5. And I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See how that's 11 places to the right? Why did I put zeros? I don't know what those digits are. So I've just got to put something. So I put zeros so that we can just get the decimal into the right place. Put in the commas. So there it is. That's a gigantic number. Now, I don't know how accurate. What does it want? What does it want? Find the size after 5 hours. So let me, so there's our number. Our number is, that's 251. It's 251,658,240,000. Again, those 4 zeros at the back, I'm not sure about. Let me go to the actual homework and see how picky it is and what it wants. So I'm going to go there with you real quick, and see how picky it is. This is 6.7, exponential on logs. This is, what number was this problem? Number 5. All right, so you're seeing my screen. Okay, so the first answer, 4375. Does it want that rounded to a whole number? So I'm gonna check real quick, and then this one, oh well, they got one that's not too terrible. Let me get a new version that goes further. Yeah. So I guess they want you to type it in just like that. Mine was a faster grow, right? Doubling period is 10 minutes. 10 minutes time material was, yeah. So they got a really, really big one. What's their 1, 2, 3, 5, 6? And then, yeah, same kind of number as us, 41 billion. So mine's a little bigger, but yeah. So they just want you to type it in, and you can put zeros at the back. They will take it that way. It looks like that's, oh, and they do want decimals on the first answer. Yeah. So, and then they will take that second answer. Just put zeros at the back. That's as close as you need to get on that one. So that looks good. Looks like they'll take it. Let me go back to the iPad. And so there we go. Yeah. So there we go. So let's recap what just happened. So when they give you a question where something's doubling or halving, you start with the doubling formula or the halving, in our case, doubling, so times 2. A equals P, 2 to the T over doubling time. They give you the doubling time is 10 minutes. That goes underneath the T. And then the initial information at 80 minutes, it was 60,000. So I plug in T equals 80. The amount was 60,000. I'm able to solve for P, the only letter there. P, that's the initial amount. P is always the initial amount. That was the answer to the first part. And then secondly, they say, what's the size of the population after 5 hours? So that was step 3. Plug in the final time, 5 hours, 60 minutes, that's 300 minutes. So I plugged in 300 minutes for time and 234.375 for P. And then I multiplied that out. Got this weird thing on my calculator with an E11. So you need to know E11 means scientific notation times 10 to the 11th, which means move the decimal 11 places to the right. So you go 1, 2, 3, 4, 5, 6, 7, as far as you can go on your calculator screen. That's how far my screen goes. Yours might be different. That's fine. Afterwards, you're just guessing at the digits. You don't know. Just go ahead and put in zeros until you've done a total of 11 places. And you're thus all the way to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. There's the number. I really don't know what those last digits are. We'll just say they're 0. So there we go. It'll take those answers. That's just an estimate. 251,658,240,000 bacteria. That's explosive growth, isn't it? That's exponential growth. It exploded. The number of bacteria just took off. That's what they refer to when they talk about exponential growth. When you have the letter up in the power zone, things happen quickly, powerfully. And so if the population of bacteria is doubling every 10 minutes, you give them 5 hours, they're going to go crazy. They're going to have 251 billion bacteria. There we go.